So let's look at another way of finding the turning point of a quadratic function. So this is called completing the square. So let's just talk through it first of all, and then we'll go and we'll have a look at it in the graphical calculator. So let's say for example we have this function here, 2x squared minus 8x plus 9, and you're wanting to find the turning points. Now whenever you work out the points at which it crosses the x-axis, that are the roots, you find out that that's got no real roots, so it doesn't actually cross the x-axis. So the previous way that we used in order to find the turning point, which were work out the points on x-axis and then work out the distance that's halfway between the points, and we know that that's going to be the x value of the turning point. Well, we can't do this here because they just don't pass the x-axis, and of course we could use calculus to do it, but let's just say we're going to use this other method that's called completing the square. So what we'll do is we'll simplify this out and we'll take it down to the lowest common factor here. So we'll take the 2 out, so it'll become x squared minus 4x plus 9 upon 2. Now this is the little part about completing the square, and it's quite simply done. What we do is we take the value here, 4 minus 4, and we half it, and then we square the whole thing. So this whole thing becomes x minus 2 all squared. We still have our 9 upon 2 here, but the thing to note here is that we've now got an extra factor, because this is going to become x squared and it's going to become minus 4x, which is correct, but we're going to end up with an extra factor of plus 4 from this. So we can't say that this is equal to that yet because there's an extra factor of 4. But all we need to do is just take that 4 off. So there's a 4 we're taking off here. Now I suggest what you do is you just write this down and just write this as x minus 2 in brackets x minus 2 and just multiply the whole lot out, and you'll see that extra factor of 4 there. So then we just add these two together, so you're going to have 2x minus 2 all squared, and this will be equivalent to 9 minus 8 upon 2, so you get your 2x minus 2 squared plus a half, and then you multiply out and you get your 2x minus 2 all squared plus 1. Now the thing to note about this is that this whole term here, well, it's squared, and because the 2 is positive, this whole thing is going to be a positive value. So it means that the term here, x minus 2 all squared, is always going to be greater than or equal to 0, irrespective of the value that you choose for x. So it means that we can find the minimum value of y by putting in a value of a value of 2 for x. So that becomes 2 minus 2, which is 0 squared, and the whole thing becomes a value of 0. So we'll just be left with the y is equal to 1. So we can see here that whenever x is equal to 2, we get the minimum value occurs at y equals 1. So it means the turning point is going to be 2, 1. Now doing this, completing the square, is just a matter of practice, and once you've done a few of them, they become quite straightforward. But what we want to do is we want to plot this function out, and we want to plot it out like this as well, and we'll just see that both of them are the same, and we'll see that the minimum value occurs at 0.2, 1. So let's go and we'll put that in the graphical calculator, and we'll see that now. So let's put our function in. So it's going to be 2x squared minus 8x plus 9. So this is our function here, and let's check the turning point. So you can see the turning point is indeed 2, 1. So completing the square does work, and you can see the reason for using it here. If we weren't using calculus, then the only other option we had available to us would be looking at the points at which it crosses the axis and then taking the midpoint between those, but it doesn't cross the axis here, so we can't use that method. So completing the square is another method that we can use whenever the function doesn't cross the x-axis, meaning it doesn't have any real roots. So thank you for listening to this video. I'll get you on the next video. Goodbye.